Hello and welcome to my session on Duckdb, my new favorite coding tool. It's a database solution from a little nonprofit in Denmark. They have a for-profit version called Mother Duck. And the reason why I made this video is I really like Duckdb. It's made a huge impact on what I do. The biggest of which is that I don't really need to rely so much on cloud services now to do my heavy lifting for data processing. DuckDB is so efficient, I can do a lot of work on my desktop now, and it's been really wonderful. So let me take you a quick tour through it and just a couple updates on what's going on. You'll find all the code in the GitHub repository that I'll post in the comments. So here we go. I'm not the best at Markdown, so somebody could help me with that. The first thing I wanted to call out, and it relates to Python in general and DuckDB, is this term called enshittification. Sorry to swear, but it's a real thing. A really great journalist called Cory Doctorow came up with the term, and it surfaced in court documents at Google that they actually discovered they could make more money by making the Google search less accurate, therefore forcing people to spend more time searching and seeing more ads. It's a little sad because I really like Google. And you can see similar things going on at Facebook. Facebook's all ads now. Amazon, trying to find the right thing to buy, and you're sifting through all the people that paid to have advertisements that may not be the best product. I also included an article there. Costco, one of my favorite stores to shop at, they're having trouble now finding quality merchandise to put in the store because private equity, the people that buy companies, suck the life out of them and then dispose of them, have bought a lot of Costco's suppliers. And it's affected the quality of the stuff you can buy in Costco. The other thing, and we're going to touch on this in the video, is that Elon Musk came out and said, we've exhausted the sum of human knowledge in AI training. This is a couple of weeks ago. This is August of 2025. We're recording this. And this is important because if we've run out of things to index on AI, what does that mean? And in the short term, it means we're being forced to create simulated or synthetic data to train AI on. We're going to create some synthetic data here for DuckDB to crunch. The reason why is I typically work in healthcare, and we don't want to expose anybody's personal health information. We want to have a synthetic data set that is capable of expanding and testing DuckDB's capabilities. I also put a link in here. SDV is a much more advanced tool for creating synthetic data sets. Maybe we'll do another video on that. So here we go into DuckDB. Duckdb.org, I had it up at the beginning of the show, and their pay version, Mother Duck, which is essentially a cloud version. Okay, they say similar to SQLite. I think it's so much more powerful than SQLite. It's hard to really compare. It's pretty well integrated into the Python environment and other tools within Python. It's designed to be a transaction processing data set. It's not really designed for multiple people hitting it at once, changing multiple areas of the data set. It's designed for single users doing research. And if you want the full-blown multiple user one, you have to go to the Mother Duck. There's an advantage in here in columnar storage in terms of the way it organizes its data and accesses it. I'm not an expert in this. All I can tell you is that it's amazingly fast and efficient. It also has the ability to run from disk or from memory. The default position is from memory. So if you have larger data sets than your RAM, don't worry about it. Duckdb can handle it. The other thing, just in general, that I really love about Duckdb is that when you think it's complicated, it really isn't. And the hardest part about learning Duckdb is that you'll approach the problem in a very complex way. They've already thought about a really simple solution, and it's just beautiful. And I wanted to show you that as well. I'll talk about that as we go on. The couple things I'm going to hit on in the presentation are using the describe function, use of new types of SQL clauses like group by all, excludes, things like that, pivoting data, which if you are in data science and you have to pivot large tables, it does that with extreme efficiency. So let's get going. I use a package called Faker, which is pretty interesting actually, to create my synthetic data set. We're going to fly through the synthetic data set part of the presentation. All we're trying to do is have no PHI, and you can control the size of the synthetic data set to test Duckdb and run processes against it. So here we go. Faker's in there. We've installed Duckdb. The other thing to talk about is with a lot of complex data sets, the install process is fairly difficult. With Duckdb, that's it. You're done. Just a simple pip install. There is, by the way, a full-blown editor that sits on your desktop that is very good. It also has graphing built right into it for Duckdb. I put the link there in the commented out section. We're not going to talk about that this time, but it's definitely something to be aware of. Okay, so let's make our synthetic data set. We're just really interested in people with diabetes, hypertension, high cholesterol, a few other problems here in terms of diagnoses. I'm splitting up gender to make it real between certain diseases only occur obviously with women, ovarian cancer being one of them. I'm not really going to get too down into this, but one of the things I did to try to make the data set more realistic is to artificially increase people's BMI, systolic, their blood pressure readings, cholesterol, just to, if we did a statistical analysis, I didn't want it to be completely random so that these people would stick out. And I'll show you that in a minute. So the whole idea is I just tweaked the data a little bit in the synthetic data set so that we could play with it and it would be more like real life. So if you have a diagnosis of high cholesterol, you should have a lab reading of high cholesterol. So we generate all that. And by the way, 10,000 is the number I picked here to, where is that variable? To simulate our data set. You can make it as big as you want. I just wanted to keep it at a small number. The longest part of this process is generating the data. There's my patients right there, line 109. So if you do 1 million, even on a multi-core machine, it's going to take a little bit of time. This is not Duckdb. This is the Faker package doing this. I export everything to pandas data frames as well as the Duckdb data set that automatically gets created in my home directory. And I'm also doing CSV outputs. I don't know why, I just decided to do that. So let's take a look at what we have here. So I'm kind of basic here. I didn't want to have a lot of separate cells here. Let's look at our patients. Oops. No, we didn't want that. We want to display patient's data frame. Just to give you an idea what the data looks like, everybody's got a patient ID. The names are completely random. They're not real people. The ages are random. The genders are not really random. They're even. And the cities and everything come out of the Faker package. Uh, I don't think they're real, and that's just what we want, not real stuff. So that's your patients. So these patients might have had visits. Okay, so they get a visit ID. The patient ID is in there, so we can join on it. And the hospitals, again, are completely made up. They're not real, nice and synthetic. Last thing I'll show are the diagnoses. Okay, they're very simple. I didn't have ICD-10 codes. I just want the common names and the tests that we're running. There's no drugs in here, but I could have done that as well. These are my tests, and it's pretty simple. Everything's random with the exception of people that have high cholesterol. Okay, so that's our data set. You can play around with that. Print. Let's print. This is how we connect. So we're doing connect to Duckdb. Again, it's in my work. I hate these pop-ups. In my working directory, I called the data set medical underscore duckdb.db. From that, I want to select just the first 10 rows of the patients, and I want to print that. So that's what it looks like. Pretty simple. One of the unfortunate parts of using Duckdb from Python is that all your SQL code is enclosed in quotes, and you don't get error feedback and things like that. It's a little ungainly. If you want that, you can go to the desktop version and test out your code there. Okay, this is really cool. So there's a couple features in here. So if I run this query, I'm joining my visits, diagnoses, and tests, and I have a whole bunch of variables I want to pull out, and that's what it looks like. But say I want all my variables, but I just want to exclude doctor. Oh, whoops, I just did that. These are all my variables that I've spelled out here. But then if I want to just say all except doctor, I can do that. And it's very easy. It saves you a lot of typing. Okay. The same is true with group by all and order by all. So say I'm doing an average. I want average age. So then I'm going to need to group by. If I were changing the number of variables in my select clause, I would then, in a traditional SQL world, need to change my group by fields as well. But with the group by all, order by all, I don't have to mess with that. And I can't tell you how much time I've spent tweaking SQL code for very long select clauses. This ends that. It's really nice. The pivot statement. So let's look at the visits data frame. Go back up. We're going to pivot it. So right now, the visits data frame is organized by visit ID and patient ID. Okay? And that's fine. That's how it should be. But let's say I want to change the orientation of this data set to be focused on hospital. So let's do that. So here we're going to pivot on hospital state. Say you're doing a data science task. You want to look at performance by state, and you want the data set organized by hospital state. Let's do that. This is a very very memory intensive task because it needs to save a matrix of the data frame off as it reorganizes it. And it has proven to be very difficult for me in the past. So here I pivoted, say that 10 times quick. So now my hospital state, is how I'm organized. And let's take a look, scroll down. I've got my dummy variables now, my one hots. And it's just, I'm all set to put this into a data science model. And it was extremely fast, 0.1 second on 10,000 rows. Very helpful. Okay, graphs and charts. All I'm doing here is I am just very quickly checking that I have skewed my test results on purpose so that they'll stick out in more of a data science. We're going to do a categorization exercise in a minute. And what I'm looking for are increasing levels of blood pressure. So you can see I have that for decent runs here. The horizontal axis being dates and the vertical being blood pressure. Same with BMI. We want artificially rising over time. And cholesterol. So sklearn, I call it an integration. It really isn't. So I think it's a bit of a misstatement. What you can do here is use Duckdb to get yourself a nice big random sample of an enormous data set very quickly. Or you can feed it the whole data set if you want for analysis. Here we're doing a classification exercise. The whole idea is they work well together. They're not necessarily integrated completely. You can't send a Duckdb data set directly to sklearn just yet. So here, what we're doing is we're connecting to our Duckdb data set. We want to pull back the cholesterol diagnosis and test data. Okay, so X is our feature set. We're looking at cholesterol, and Y is the target variable. Let's let the machine determine what is associated with high cholesterol or cholesterol in general. What diagnoses are associated with that? That's the problem we're trying to solve. So here we're splitting our train and test. We're using random forest classifier in sklearn, and then we're fitting our data. We're doing our labels for each classification. So let's see what that looks like. We'll run on the full 10,000. So you can see here I put in a little guide for what our output and how to interpret it. If you look at high cholesterol, your recall, which is your sensitivity to find the relevant class, is 80. That's not super great, but I'm just doing a test here. The whole idea is you can take this code and modify it to your needs, and using real world data, you may get a more positive result in terms of its ability to classify certain diseases or whatever else you're looking to do. The value here is that if you have a data set that's just too big to process with some data science model on your desktop, you can just do a partial or a representative sample of that data and then run it through. Okay, so another thing that Duckdb does really well, is processing data from JSON files. So it's got an automatic JSON interpreter, which is really nice. We're going to look at this Microsoft sample data set here. It's in JSON, and you can see if you're not used to JSON, it can be very difficult to get back out of this format because of the various nesting levels. So if you have a JSON data set, don't worry, Duckdb can help you. So what we're going to do is just pull this down from the web. The Duckdb has the ability to interpret that raw JSON and figure out how it's organized and put it into a standard data frame. It's pretty nice. So here we go. This is a data frame interpreted from JSON. You didn't have to do anything to get it that way, which is very nice. Duckdb has another really wonderful addition to it in what's called its community extensions, called the property graph query. And if you're familiar with graph data sets, or if you're not, they're very powerful tools at arranging your data that works very good for things that are relationships between certain entities, such as, in this example, nodes. This is how graph data sets are organized. So patients, they would be a node. And in the patient node, you'd store data like their ID, their name, age, gender, things like that. Then the visit node would be their IDs, the doctor that saw them, the hospital, where it was, the date, things like that. The diagnosis node would just have the properties of the diagnosis itself, so like high cholesterol, and links to the visit ID and patient ID. So the whole idea is you join these nodes with edges, and the edges determine, what happened during that visit. What are the links between visits and people, the links between diagnosis and visits. So I'll show this to you in a graphic format in just a second. The advantage with Duckdb, again, is fantastic speed and efficiency at processing these. So let's turn our tabular format that we've already created into nodes and edges. So here we go. We're going to start making our nodes. These are just SQL queries, okay? And we're going to construct them just the way we did here in the markup. So we make our patient nodes, our visit nodes, the diagnosis nodes, and then the edges, okay? So these are all our information we need to make a graph data set. And this takes, let's just run this. Again, 0.1 seconds, we did it. We install the PGQ community package, property graph query. Sorry, I stuttered there. And that gets us the ability to interpret a Duckdb database as a graph. So there's your code to do that. I hope Duckdb keeps going with this because it's so powerful. And pretty much any other powerful graph package in Python, you have to pay for. And this is wonderful because it's free. So let's run a query on this. Let's get the top 5 patients with the highest BMI and their diagnosis and doctors. Okay. And we're doing that based on the nodes and edges that we've organized in the previous cell. So let's run that query. And it returns the data we would expect. The advantage of a graph data set, though, is not so much that it will give you the top 5 patients and their associated tests. It is in the ability of a graph data set to get degrees of separation away, which would normally be represented by a join. That process is native to a graph. So if you said, I want to get everybody that had this diagnosis and the next 3 diagnoses in order of time from a data set, you could do that very easily. whereas in a tabular data set, it would be very difficult. So let's plot out our data set. So here we go. We're connecting again to our medical_DB, and we just want to have, because graph data sets can be a little difficult to read when you're looking at everybody at once. So we're just going to do one random patient at a time. And we want to see their diagnosis nodes. We want to see their test nodes. And then we just want to put all that together with that one random patient. We're going to use NetworkX, which is a wonderful graph database package. Duckdb does not have a graphing capability in Python, unfortunately, and certainly doesn't have one for graph data sets. So you have to convert it to something else. We're converting it to NetworkX. Okay, so from here on, we're in NetworkX. Okay, so let's look and see what one random patient looked like. Oh, gotta run our code. So here we go. It's a little crowded. The red dot is the patient, okay? And you can see that they had a visit, and then in that visit, there was a diagnosis for ovarian cancer in the green dot, okay? Again, this is all synthetic database, not real people. This is a little noisy. I'd probably get rid of the loop, the visit test back into the visit node. But again, your nodes are people, their diagnoses, visits, and tests. And the advantage is, of course, visualizing this so you can see the patterns, and also linking them together in ways that are very difficult to do in a typical tabular data set. Thanks so much for listening. If you liked what you heard or have comments, please leave them in the comments section, and or follow me. Appreciate it very much. See you next time. Bye-bye.